Okay, hello everyone. Okay, can you hear me?
Yeah, we can.
Okay, good, great. Okay, let me share my screen. Okay, hello again. My name is Sarwar Abdullayev. I'll be teaching you Java programming this semester. And today we'll do our first real-time interaction session. And during this session and maybe the next sessions as well, we'll be doing a lot of some practical work. And I'll show you how to do it, this kind of practical work yourself as well. So this part of our activities is called labs, okay? And we'll be doing the labs together. Okay, so let me go and start from our page where we basically have everything, including the lecture videos and everything. So, so I'll show you how to go and start doing the lab exercise and then submitting your lab exercise back into the system. So first, you just need to go and log into this to our system, okay? And here you're going to find every week you're going to find some topics here, okay? Lecture 1, lecture 2. So this is a second week, and we have lecture 2 here. And if you have already watched the videos, you probably know that in this week we talked about the Java fundamentals, and we discussed about the basic syntax of Java, okay, and solving some simple problems using Java, taking the user input, okay, outputting something to the user. So these important concepts have been covered in this particular class. And yeah, if you have a prior knowledge of Java or C++ or any similar programming language, then perhaps this particular class was quite easy to you, but that's fine because we just do some recap in order to make sure that everyone actually understands and actually the same concepts in the same way. Okay, so again, you can watch the videos by just clicking into this link. Don't forget to do your attendance quiz. The deadline is usually the Monday of the next week. Okay, so how are you going to start doing your lab exercises? Okay, so the lab exercises, you always now, starting from this week, you'll have a special link here called Lab 1 or Lab 2, Lab 3, and so forth. So what you're going to do is you just need to click this link. And currently it says that I already accepted, okay, this lab. But in your computer, if you go and click this link, you're going to see the list of student IDs, okay, and your names. You're going to see that on your computer. Because I already accepted it, it's not showing me that list. But you have to see, you should be able to see that list. And in that list, please choose your name, okay? Please be very, very careful before choosing. Don't choose someone else's name, okay? It's very important that you choose your name. And when you're choosing this name, your name, you should be logged in with your account in GitHub. Don't use someone else's account and then choose your name, and then this kind of problems happen a lot. Don't do this. Make sure that you are logged in with your profile, with your GitHub profile, okay? So you should be able to see that you're logged in with your profile here. And so you can see that, okay, this is you, and then you can go and click this link. And if you go and click this link, it will show you the list of, okay, students. You choose your name there, and then it will ask you whether are you going to accept this assignment. You go and click the button, and you're gonna see something like this in a couple of minutes, I guess. If you don't see something like that, please refresh your screen browser, and you press this one, and then you refresh, and then you'll see something like that. Can everyone see this page on their screen?
Yes.
Okay. Anyone? Everyone?
Yeah, we can.
Yeah, we can. Visible.
Okay. Okay, it's visible, right? Good. So yeah, if you don't have any problems with that, then you can go and proceed to the next step. In this case, you just need to go and click this this link, okay? So what's actually happening here is that this GitHub Classroom is creating you a repository, a new repository for your task. And you'll be basically doing some programming, and you'll be doing your programming classes here, right? So, I mean, I also turn on the REPL thing on to make sure that you can go and do your programming online. But I don't recommend it because it's better if you do it on your computer. What is REPL here? You can see this particular icon here. It means that you can go and program this whole project. This one, you can see I already submitted this project because I did a similar RIS session with other group, but I'll do it again, no problem. Okay, so the point here is, obviously you don't see this source folder. You're going to see some files here, and then you're going to find out that you'll have this lab1.pdf file here. Okay, that is what you're going to see on your computer at the first time, right? So do you see this kind of screen here in your computer?
Yes, I can.
Yeah, everyone? Yeah, so please, if you have any question, I mean, anything, like, please write in the chat or write this one so we can kind of be on the same page. Okay, cool. So so what we're going to do is, so once you have this thing, okay, the next thing you're going to do is you have to go to you see this code here, you go and click this drop down, and here by default it will be selected like this, right? You go and select this one, this particular HTTPS, not SSH. Go and select HTTPS. Okay, you first select HTTPS, make sure that this link starts with HTTPS. Okay, and once this link starts with HTTPS, you go and click this clipboard. You click clipboard, and now you copy this URL, and you need this URL to clone this particular project into your folder. And we're going to do this right now. Okay, so yeah, so what I'll do now is I just copy this, right? And I'll go and so I got labs, so I got lab repo, right? So yeah, let me just remove this. Okay, let me go and create a new folder. Okay, it doesn't matter where you're going to do it. Maybe you have some folder called Java programming, and there you have a labs folder. Inside that, you got a lab1 folder. You can do that, or you can just do it directly inside labs folder. I'm just doing it in my lab1 folder. Okay, so I'll go and create a solution, something like that. And here inside this folder, in this folder, what I'll do is I'll open, okay, git bash. So how to open this Git? First of all, you should be able to have Git installed on your computer in order to work with that. So in order to install Git, you have to go to Git download, and you just search Git download, and then go to Git downloads, and then download Windows. I already told this in the first week. You had to go and install this particular, which depending on your operating system. Okay, you had to install this libraries, okay, this components. So if you're using Windows, you just go and download this particular, this one. You can see this link here. Just go and install it, and maybe after installation, check if you have in your context menu this link. Okay, you should have this link in your context menu. Okay, if it's not there, then something went wrong with your installation. Maybe you just go and reinstall or uninstall and reinstall again and see if installing everything correctly. Okay, so once you go and go to this git bash, and once you open this git bash, you're gonna see some console here. Okay, so this is the console, and in this console, what you're gonna do is, you remember we went into our repository and then we copied this URL, and make sure that it's HTTPS. We copied it. We'll come back to this console and make sure that this console is indicating to the location on which you're going to do your lab. So it's in the same folder. You're going to look into the folder here. So what you're going to do is you're going to say git clone, and then you paste the URL that you copied here. Okay, so you do the paste, and then you press enter. Okay, so once you press enter, it will go and download. Your repository into your local computer. And now you can see this folder here. And in this folder, you have everything. Currently, you have this source folder, but I mean, I have the source folder, but you won't have the source folder. Okay, you'll have something like this. So I deleted this source folder, and this is what you're going to see at least. Maybe this git ignore will also not be there, but okay, this is just okay. Someone is saying this. Okay, how to find that URL? Here you can see code, and here it's here. Okay, don't press this button. Don't never ever go and download your repository like a zip file. Don't do this. Okay, don't do this. This is bad. Don't do it. Copy this URL. You got it? Just go here and then copy this URL and then do whatever I just showed here. Anyway, no problems. Okay, if you missed something, no worries. I'm recording this particular RIS meeting and I'll upload it to YouTube, and you can just rewatch it again if you just missed some part. Okay, so that's not a big deal if you missed some part, because we just need to cover a lot of things, and we cannot move in a very slow pace. Okay, so so what's going to happen next? Okay, no problem. But if you have any problems in understanding what we are doing, go ahead and ask, because that might be helpful to others as well. So you go and ask. It's an interaction session anyway. You have to interact with me, and you have to ask questions during this session. Okay, so what we have here is we have this particular folder, and inside this folder, we have this file called lab.pdf file. So this is the important file. You'll always have this file in your task, in your lab assignment, and inside this task, you're gonna have some lab assignments. Okay, things that you should submit into this GitHub repository. Okay, so just for now, ignore this this instructions. They say you have to submit it to eClass or something like that. Ignore that, because it's been just left from the last year. You're not doing any eClass thing today this time. We're doing everything in GitHub. Okay, GitHub Classroom. So we are not using eClass. Okay, and we are submitting things into GitHub Classroom, and I'll show you how to do that later on in this RIS. So now you can see that we got 8 different lab exercises that we should submit individually to GitHub. Okay, and yeah, these assignments should be submitted individually, but again, as I said before, you can go and organize yourself into smaller study groups and do those things together. Okay, so it's a place where you should collaborate, you should exchange, and you should solve these problems together, and through that you'll be learning. Okay, so that's very important. So if you have any problems, or if something is not working on your side, you can do it with your friends, and your friends can help you, or you can help your friends. And the reason is, okay, this way you can teach your friend to do something that he's not understanding, and at the same time you together solve the problem. And it's kind of it's better to learn this way than just watching lectures. Okay, so this is kind of my experience as well. So that's why this particular lab exercises is a platform for you to collaborate. So go ahead and be as helpful as possible, and collaborate, and you can even share your code, because your lab exercise, I mean, you will not be graded for how well you did in this lab exercise. What we're going to do is simply just check if you completed the exercise or not. If you completed all of these tasks, okay, and not even if you completed it wrong, okay, it won't count. It will count, because you made an attempt. Okay, so, and that's also important. So we're going to check if you made an attempt to do this particular exercise or not. And if you made some attempt, and no matter if it's producing right results or wrong results, it's still going to be considered completed. But you have to do an attempt. Okay, if you don't do an attempt, then obviously it won't be counted, and your lab will be not counted as a completed one. Okay, so that's important. Okay, good. So okay, so what we're going to do is we'll go and do these kind of exercises. And during the RIS session, I'll be doing not all of them, but a couple of them, maybe the ones that from the top and maybe ones from the bottom. Okay, so and I'll leave some of the exercises for you to do it yourself. Okay, so some parts you should be doing yourself, some parts I'll be helping you. Okay, I'll be just showing you how to do those things. Okay, on my computer screen, and through that I'll be just kind of teaching you in real time. Okay. Those things that we covered during the lecture. Okay, someone is asking a question. What is that? What is the source code of 3 friends who okay, it's fine. Okay, again, the point here is if you have, someone is asking, it's a good question. Someone is asking a question about what if we have, like, we work like as a 2-3 friends and our code is very similar to each other. Okay, this again, I already told about that case in my cheating policy, and this case is acceptable if you have a similar code across, like the same code like your friends. Okay, that is also acceptable, but you have to do it yourself. Okay, so you have to submit your work yourself. You should go and type it in, like whatever your friend did, you have to do it yourself. Like, try it. Okay, this way you're going to make sure that at least, even if you don't understand something, you're like putting some effort, and just copying your friend will also teach you something in some perspective. But this is something is just a kind of a last resort. Okay, when nothing is actually working, and you tried this and that and didn't work, okay, then maybe just go and try whatever your friend did and it worked for your friend. Okay, so this could happen, and that's fine. All I care in lab assignments is the participation and your effort. So if you show that you put any effort in doing these exercises, no matter you're seeking help from your friend, it's okay. Okay, if you show that during the lab exercises, that's fine. Then I will count it as you participated in the lab. You sought help, okay, from friends, from me, okay, and from anyone who you think knows how to do proper Java programming. That means that you're trying to learn, and that is good. Okay. So, but you can do this kind of collaboration, you can do this kind of thing only during the labs, not nowhere else, not in the exams, not in the quizzes, not in the in other assignments. Okay, you can only do this in the labs because you guys want to help each other. I just made it possible for you to do it. I made a special lab exercises just for that, because you guys want to help each other. And this is like, it's been like 4 years I've been teaching in high university. I know what students normally think, how they think. They normally want to help their friends. Okay, if you want to help your friend, labs are the great place to do that. Okay, and please do it during the labs. But when it comes to other places like midterm final, okay, then please do it yourself. This way, if you help your friend, then you'll be caught as a cheater, and both of you will get 0. Obviously, this is not how you're going to help someone, okay, to learn. So, so this is my policy, okay, and I think this is it's going to work well, especially during this pandemic time and during this online teaching process. Okay, so there is a question regarding the third program. Okay, Farhad, I've asked it. Okay, you ask this question, okay, when we come to this particular question. Okay, so let me first start doing these, maybe the first exercise, and then once I finish this first exercise, maybe you will ask your question related to that. Okay, so right now let's not jump into your third question. Okay, let's start doing the exercise first, and then in the process you will ask the question that is related to this particular task. Okay, good. So I think we are done with the logistics of lab assignments, but the only thing is I haven't shown you how to do the submit part. So you already have the download part, but now you have to start working on these exercises. So how are we going to do this? Okay, and how are we going to do this? So the first thing that you're going to do here is you should first of all install the IntelliJ, the latest edition on your computer. Okay, so again, IntelliJ is free if you're an in-high university student. Please make sure that you sign into IntelliJ IDEA with your university email address. Okay, so IntelliJ IDEA. Okay, if you go and say download, it basically, you can go and download the community edition for free. But if you want a more complete edition, ultimate edition, you can also download that one. Okay, and it will be free for you because you're a student. Okay, so again, go and sign in to your account and then download and install. I'm pretty sure you already did that. So you just do this, and once you've done it, you'll have some IntelliJ installation or file on your computer. So what we're going to do is we're going to start this IntelliJ environment, okay, on our computer. So let me close this bash. So now I got I got a community edition, so not the ultimate edition, but again, so you might have the ultimate edition too. But for now, we'll just need a community edition, and we're not like right now at this moment, we don't need something more advanced at this moment. Okay, so what we're going to do next is it will ask you whether you want to create a new project or want to open or import something. So what we'll do is we'll go and create, we'll go and say a new project, not open or import. We'll go and create, go and click new project. And it's important that we say new project because this one will cause some problems. Okay, don't go and click open, go and click new one. So it goes and creates a new project. But before going and creating a new project, it's going to ask which project you want to create. So we will say I would like to have a simple Java program. By the way, I also ask you to install Amazon Corretto. Okay, Java's Amazon Corretto distribution. So you can go and search Amazon Corretto. Okay, and you had to install the 11th edition of Amazon. Everything is clear. Can you see my screen as well?
Yeah.
Okay.
Yeah, Professor.
Yes.
Okay. Yeah. Okay, good. So yeah, sorry for the inconvenience anyway. So so you just need to go and you had to go and download and install this Corretto. Okay. Did everyone install this distribution Corretto 11 on their computer? Did everyone did this?
Yes.
No problems on that? Okay, good. So
Professor,
yes.
can you use another JDK from Oracle one? Not
Yeah, I mean,
Corretto one.
yeah, so they've been students asking about that. Again, although the differences are not very big, I mean, there are very small differences in different distributions. In fact, they are basically the same. I still recommend you to go and use Corretto because, I mean, I've been using Corretto in a previous semester classes, and it's been quite good. I mean, but again, if there is a problem in the versions, right, in the versions that you installed on your computer, and a certain feature of Java that we are covering is not supported, then we're going to have a lot of problems. I mean, at least you come and say something is not working on my computer, and we should go and try to debug it, and this could kind of take a lot of time. So instead of in order to avoid all these kind of problems in the future, I still recommend you to go and install Corretto 11. But if you already kind of use Oracle JDK, and if you already have Oracle's JDK, Open JDK, then that's fine. Just go ahead and use Open JDK on your computer because Actually, you don't need 2 distributions of Java on your computer unless you're using some virtualization or anything. But if you don't have Java on your computer, if you never did anything on Java before, then I recommend you to go and use Corel 11. Okay, if you've been doing something on Java previously and you've been using Oracle JDK, that's fine. Just stick with that JDK. There shouldn't be any problem with that. Is it clear?
Yes, thanks.
Good. So once you have this thing, okay, you should be able to go and create a new project. So remember, we are creating a new project. We are not opening something. So we go and press next, and also we press next. And here, okay, here I just need to go and first give some name to this project, but I can go and go to the place where I downloaded, where I cloned my task, okay? So I can go and I remember that place. It was in the labs folder, lab 1, and I got a solution folder here, right? And inside the solution folder, I had this particular folder. So I have to go and select this folder. Okay, so this is important that I select this folder, not any other folder. So don't go and select some other folders. Please go and select the folder that you just cloned from from the from GitHub. Okay, so this way you just go and create a new application. So it goes and automatically sets the project's whatever name to the name. Just leave it as it is. Okay. So that's very important. So you select that particular folder and then you press finish, and it will go and create a project folder in that directory. So now you're going to see, okay, something like this on your computer, and it will go and automatically create a source folder on your computer. Okay. So okay, so now this source folder is empty, and but still now we can go and start doing our programming exercises. Okay, so we have our programming exercises here. So now we are ready to start our programming exercises. Okay, so what is the first programming exercise? Let's go and read that first, and then do it together. So we should go and create a simple calculator for body mass index. Okay, it's it basically counts. It takes as an input, it takes the weight and the height, weight in kilograms and height in meters, and then calculates your body mass index. Okay, so based on that body mass index, it tells to which category you belong to. Let's say you can be overweight, you can be obese, or you can be normal or underweight. So depending on your body mass index, you can go and figure this out. And this particular algorithm, the program has to do that. So the formula for the BMI is very simple, and the ranges are given here. Okay, so we just need to go and create a simple application, simple program that will run this particular program, and then it collects the user input, and then it returns us our body mass index and let's say to which category we belong to. Okay, so let's go ahead and start doing that. So first thing that we're going to do is we always go and create some, let's say, app class, which is going to be our executable class. Okay, something that we will be executing in our program. So our executable class will always have public static void main. Okay, and so it will go and have this particular set of arguments. Okay, so this is the standard Java method for creating some executable classes. Okay, so inside this executable class, we will be doing something useful. Okay, so let me go and first do some simple testing. So I'll go and say system out print ln, and I'll say hello world, just to make sure that my executable class is actually running and it's printing out some simple message. Okay, so what I'm going to do here is, now do you see this particular play button here? Okay, so once I go and finish my code, remember I put this semicolon here, I'll go and press this play button, and asks me, okay, which method you want to play. Okay, app.main method is the one. that corresponds to my case. So now it goes and executes this particular code. And as you can see here, it will just pop up some terminal on my computer screen, and it says hello world. So it means that my program is running, and as you can see, it's also building, okay, my class, and it's executing it at the same time, okay, okay, using these the IDE's own, okay, agent. So it does its building and everything. You can see what kind of command line it is executing, okay. So it's Java and all that stuff, but you don't have to kind of look into this right now. All you're knowing is that basically it's getting compiled and executed at the same time when you go and press this play button. And now you can see this the output that particular your program is actually producing. Okay, so now we have to go and create a particular class that is going to solve our problem. You're not, yeah, so no, it's okay. Yeah, someone is asking if it's IntelliJ IDEA. So if you have installed IntelliJ, okay, you can install both. I mean, Community Edition or the Ultimate Edition. Ultimate Edition has more features. Okay, it has, you can go and access databases using IntelliJ Ultimate Edition, and maybe some graphical tools as well. But right now we don't need IntelliJ Ultimate. I mean, if you have Ultimate, that's fine. That's great. Just leave it there. Okay. But currently I'm using Community Edition, but maybe later on I'll switch to Ultimate. But what I'm saying is, if you're a student of Inha University, you can get Ultimate Edition for free. Community Edition is just free for everyone. Okay, so it doesn't matter. So good. So if you can look into this particular your project folder structure, you're going to see that it's also producing some class files. You remember that this class file is a bytecode file which gets executed every time you call Java, this one. Okay, so this is the place where your basically your program is getting compiled into a bytecode, and then it's getting executed from this particular position, from this particular location, okay, through the JVM. Okay, so this is the place. Just keep it in mind, okay, and most importantly, you don't have to upload this out folder into your submissions. I don't care about this out folder. It's just necessary for you to run the application, and therefore I just created something called the gitignore file, and inside this gitignore file, remember it's .gitignore file, and I just included these like kind of folders that I don't really need to be submitted. Okay, so these folders, I don't need them. All I need is the source folder and inside this one. So if you just include this into your gitignore file, these folders will not be submitted back into the GitHub. But I'll come back to that point again when we do the submission. Okay, so now what we want to do is we want to start doing this exercise. Okay, so how are we going to do this exercise? So the first thing, okay, is I have to go and create a new class for that particular exercise. So let me go and call this particular class. I'll say BMI calculator. I'll go and create a new class called BMI calculator. And inside this BMI calculator, what I will be doing is I'll just go and create, I'll just go and create a new, let's say, a new method called, let's just go and create a static methods for now, public static void method called start. Okay, so this particular program, what we will do is whenever we start this program, it's going to collect the user input and then output the final result. Okay, so so I can go and do it this way. And so what should I do now? First of all, I just need to collect the user input. Okay, so for that, I'll need a scanner object. And the scanner object, as you know, it's just a parser which takes the standard input of the program and then converts it into a corresponding data type, right? So this is the standard input, and it's being instantiated with a standard input. Now we can go and use it to collect the user input. Okay, so now what we're going to do next is we're going to say system out okay, println, and I'm going to say, please enter your, let's say, weight in kilograms. So I'm telling the user, okay, to enter the weights in kilograms, and then I just need to go and collect this information from the user. So what sort of info, okay, in which data type I'm going to use to collect this information? I can go and use double, okay, because again, it could be like up to the grams. So let's go and use double. So what I'll do is I'll say double, and I'll say weight, and I'm going to say input next double, right? And what it will do is this particular next double will wait until the user goes and inputs the weight, and then once this particular parser accepts some user input, it goes and converts it into, okay, weight value. The next thing that I'd like to do is I'd like to go and say ask the user about his height, right, in meters. So, and I'll go and create double, okay, height, and I'll say input next double. So now I got both weight and height. All I need to do is I just need to go and calculate the body mass index, right? So how do I do this? Okay, I'll go and say double BMI, okay, and what is that equal to? It's equal to weight divided by height squared, right? So it's pretty simple. So I'll go and weight divided by, I just need to find the height squared, okay? So I can say height, and the power is 2, okay? So I can go and use the math package here and its power method to find the square of this one, or I can just multiply it twice, okay? It doesn't matter really. Okay, which one you're going to use. So now I got a body mass index, right? So the next thing that I'd like to do is I'd like to find out to which category this particular BMI actually belongs to, right? So I have to go and find out that. So how can I go and find this out? So I'll simply go and use if statements for that. So if body mass index is less than 18.5, so let me go and create a new variable called category. Let me just first set it to empty string, right? So this is these are the categories. I can say if it's less than 18.5, then it is underweight. If it's between this range, 18.5 to, let's say, 25, let's go and just round it out. And this one is also from 25 to 30 and 30 or greater. So normal obese, overweight and obese, okay? So we just need to go and do this here. So all I'll do is I'll say category is equal to underweight. And what I'll do next, say else if, right? And what should I say? If BMI is greater or equal to 1.5 and, right, BMI less than 30, right? So what should I say here? Normal. And another else if BMI is greater than or equal to 30, and let's say it was 32, I guess, right? No, 25, sorry, not 30, 25. 25. So here it's 25, and BMI less than 30 is called category overweight, right? And note that I don't have to go and put I don't have to go and put else if, but I can go and put else if else, because okay, So what kind of BMI will hit this particular point? Only the one. Sorry?
Less than 0?
I can go and say explicitly like this. That will be fine too. I can go and say 30. That's fine. And it will be obese. And that's it. So let's be explicit, okay? We can be explicit. But I could be implicit like this as well, because anyway, it will be, this particular spot will be hit only if BMI is greater than 30, okay? If it's less than some number, okay, either this, or this will be hit. But this port, this one. But I want to be explicit, so I want to make sure my code is readable. So the person is reading my code understands that this is the range, this is the boundary from which we start considering people obese if his BMI is like this. So now we have to print out the output. We already got BMI, we already got the category, and it's already assigned. We just need to go and print it out, right? Also, I'll go and say print ln, or I can go and use printf. So let me go and use printf. So printf will print out a formatted text. So what is a formatted text? I can say your BMI is, and I would like to print out some digit. You belong to category 2, let's say, and this is going to be a string, right? To category. Okay, so what should I do now? So I can say BMI and category. So what it will do is it will, we're going to put F here, so this won't show this one. So what's actually happening here is, okay, I'm just specifying some string, and in this string I got some placeholders. Okay, this is a placeholder for fraction, this is a placeholder for string, and I'm just passing these values that should be filled into this string. And don't forget to put a new line, so I just put a new line at the end, so it just goes and starts the next output from the new line. So it breaks the line, okay, in this case. And that's it. That's it. We just did the first exercise. It was very easy and very intuitive, but now we just finished this. Now, the next thing that we want to do is we'd like to go and, okay, run it. So I'll just go and comment it out. Now I got this app.java file where I'll be executing these particular programs that I created here. Okay, I mean, I can go and directly execute it from here. Like actually, I can go and do that as well. But okay, in order to do this, I have to go and name it main and then just pass the arguments. I can directly execute it from here. But okay, let's keep everything in one place. So, and when I'm testing something, okay, I just want, because you might have multiple other classes in the next lectures, and I don't want to get lost in multiple different classes to find out which class is the one which kind of executes this particular program or this particular task, okay? So I think it would be better if you, okay, execute all of your tasks inside this app.class file. So this way, when I will be reviewing your code, I'll understand that the first place I have to go, my entry point, will be app.java file, and I should be able to execute all of your solutions from this app java.file. Okay. So what I will be doing next is, okay, I'll go and say comment. I'll say problem 1 solution. So I'll go and comment this out like this. So this one I don't need it anymore. So, and then here what I will do is I'll say BMI calculator start. Okay, that's it. So all I need is this, right? So this is a static method and I just need to go and call it. So let me go and call that. And now, as you can see, it's asking my weight or some weight, okay? Okay, so I can go and give some weight, okay? So for example, 75 kilos. And it's asking, let's say, height. So, and make sure that the height is in meters. So I have to provide some realistic height. So you can see it's a double, it's a fraction, right? So 1.72, for example, and it says, okay, your overweight, it's like 75, 20, 25 or something like that. Okay, so you can go and play this again, and it's basically will give you the right answer. So we basically done this with this particular exercise. Okay, good. So once we're done, we can go and comment this particular method call and then switch to the next exercise. Okay, so meanwhile, okay, like you finish this particular task, and then before you go and switch to the next task, you would like to do some submission, okay, back to the GitHub, okay, some intermediate submission, let's say, okay, not the final one, but still you want to do some submission. So how are you going to submit your work? So to the GitHub. So because you don't want to miss the deadline or something like that, at least you finish some part of your exercises. Let's go and go ahead and submit at least what you have, and then continue doing the rest of the task. And then maybe once you finish, you'll submit it again. So you can submit multiple times, it doesn't matter, until the deadline, of course. So you'll have a deadline. Okay, so how are you going to submit your tasks? Okay, so this is very important. So please, everyone, look into this, because I don't want any complaints in the future coming saying I was not able to submit because I had because I didn't understand timing, because I had some problems with the internet or something. I didn't understand how to submit. So please watch it carefully. So this is very important. This is how you're going to do the submission. Okay. So the first thing you're going to do is on your computer screen, okay, if you have installed the IntelliJ 2020 version, the latest version of IntelliJ, you should be able to see these buttons. Okay. Do you see these buttons here? Yeah. So in this, here you're going to see like this button. This is pull, this is push, and this is the commit. So these buttons have names. Okay, this is pulling, this is committing, this is pushing. So what we're going to do here is we first go and click this check button, this green check button. It's called commit button. So we go and press this button, and now yeah, it's saying you don't have this thing, you delete it. Okay, but don't worry, you're going to see this thing here. So what you're going to say is, okay, I want these changes. Yeah, I want these changes. And so the next thing is, okay, you have to go and write things that you did, at least just summarize what you did into the commit message. It's important that you go and write some commit message just to summarize very, very briefly what you did. So you can say, so you can say, you don't have to say, I completed problem 1. Okay, so that basically summarizes what you did in this particular commit. So what is a commit in general in Git? Commit is some sort of a checkpoint. Okay, so like when you're playing games, okay, you want to save some points, so next time you want to start your game, you want to start from that particular position. Okay, so when you're making a checkpoints, you can label them, you can leave some comments for that checkpoint. So it's similar in coding as well. When you program something, okay, and you want to leave some checkpoints because, like, let's say you want to return back maybe to that checkpoint later on, or like every time you're evolving your software, building your software, you're like making different checkpoints to which you basically might return if you have some problems in the future, right? So you go and create these kind of checkpoints, and these are called commits in programming environments. Are called commits, and we're creating a commit message. Okay, so this is commit. We're creating a new commit, and this new commit is nothing but a checkpoint in our program. Okay, and we would just like want to take a snapshot of our program and just save it. And the next time we will make a commit, it will also take a new snapshot, and then so forth. So we go and press commit here. Now now it says, okay, 2 files committed, and you will see something like that. It might go and ask you to give your GitHub credentials if you're doing it for the first time. So you might need to go and sign in to GitHub credentials and so forth. But still, it's okay. Just go and create. Now you press the commit, and your file is committed. So if you go and press this button again, yeah. So you should be able to see, okay, nothing to commit message. Okay, nothing to commit message. Okay, so I'm just seeing this thing, but ignore that. You should be, when you go and press this one, it says nothing to commit because you haven't made any change. Okay, good. So the next thing you're going to do here is you have to go and press this push button. Okay, this push button, this green arrow button pointing upwards. Just go and press this button, and it says, okay, you're going to upload everything to the GitHub. Okay, so you go and press push, and it goes and uploads everything to the GitHub. Okay, anyway, let me go and delete these files as well. Okay, because anyway, I'm going to go and create them again. So let me go and make a new commit, and then again, new submission. I'll go and press new submission. And so now I submitted, now it says pushed commit to origin master, something like that. So now if I go back into my, into my repository, that link you remember, okay, I'm going to see my commit message. It says, okay, 20 seconds ago, you made some changes. And I'm going to see my files here, right? The files that I just created. I'm going to see those files here. So it means that I just uploaded my solution. Yeah, my lab exercise, partially completed lab exercise. So now I can come and just watch, I can come and look into your repository and see these files, and I can kind of leave some comments if I want to, or I can just try to download your particular repository and execute it on my computer. Okay, so now you're making it available to me. So I can go and check them, and I can go and look into them. Okay, maybe I can do those things using REPL and so forth. So, but the point is, you actually now submitted the work. Okay, and that makes you kind of, you're free from any problems in the future because you submitted it and you got an evidence for that. Okay, so you got it right. So there's no problem on that. So any questions so far?
Professor?
Yes.
How we can delete those files?
Sorry?
How we can delete those files?
Which files?
Those files which we uploaded to the GitHub.
Oh, okay, so again, if you want to delete, if you, let's say, accidentally submitted some file, let me go and show you how to do that. So I can go and, let's say, create a new file, some random file, let's say random file, random txt. And I just created this random txt. It asks whether I want to stage this thing into, okay, the IDE will ask, okay, where you want to put it into your next checkpoint. Okay, so let's say, like, let me give you an analogy on that. Okay, so when you're creating a new file, or when you're making any new change in the new file, okay, and when you're creating a commit, it will ask whether you want to store this change or store this new file in this checkpoint. It's like, you know, you're playing a game. Okay, you're carrying guns and grenades and everything with you. Okay, in a shooting game. And then when you go and press, okay, it hits save button, and the program is asking you, okay, whether you want to keep this grenade with you next time you spawn from this place or not. So you have to explicitly declare it. Okay, you have to say, yes, I picked this grenade from the last checkpoint. Okay, so, and I would like to have this grenade in this checkpoint as well. So that's what you need to tell, what you need to declare when you're making a Git commit. Okay. So it's similar. So now I I added up this new file, and it's asking me, okay, whether I want to stage it. This is called staging. Whether I want to stage it into my next commit. Okay. So that when I do the next commit, this file will be added into the checkpoint. Okay. It will not be added. So let's go, and I just created this random file. I just go and create some random text here, and I just save this file. Okay. Now it's saved in my computer disk. Okay, so now, again, this file was kind of a random file. I didn't need this file, but by some accident, what I did is I basically added this file. So what I can do is I can go and press commit, and okay, again, you have to do a lot of accidents, okay, to upload this thing into your folder, but it's saying, okay, whether you want to upload, save it into your commit, and the checkbox you can see here, and let's say you ignored it. For some reason, you did not uncheck it, and then some random file, right? Again, this normally should not happen, but again, you're missing that point. and you included this into your commit, and then you pressed push, right? And now this random file is there in your repository, right? In this repository. So you have this random file in your repository, but now you want to delete this random file. You don't need this, okay? Again, first of all, try to avoid putting things into the GitHub that are not necessarily to be, they should not be here, okay? But again, for some reason, you basically included it. So what you can do here, okay, so you can go and physically delete this file from your, okay, from your repository, sorry, from your folder. If you don't need this particular file, you can go and delete it, okay? So most of the times you will just do this, okay? But you can also take it away from your, okay, from your commit. So let me go and delete this particular thing, okay? So I'll go and delete it. So when I'm deleting it, it's asking, okay, you want to do some safe delete. What is a safe delete? Safe delete is, okay, it will not basically delete the file, yeah? It basically deletes the file, yeah. Okay, so normally those kind of things are done. Command line, I know how to do this. But the point is you just deleted this file, okay? And now this file is gone. Okay, you don't need this file anymore. So now this is also a change to your project, right? So if you go and press commit again, you're going to see that this file is deleted. And it tells, okay, you want to register this deletion, and this is how you're going to register it, right? Saying, okay, you want to register this deletion, and you say, okay, yes, I want to register this deletion into my checkpoint. And that's why it's checked. So saying deleted random file. And then you press commit again. So now you registered this deletion to your commit. And again, you go and press push. Go and press push. And once you go and press push, now it pushed your latest changes into your code. Now if you go and refresh your repository, now you don't see this random file here anymore. You got it? And it says deleted random file. Is it clear now?
Yeah, thanks.
Professor.
Yeah. Hello?
What if I already wrote all my codes and like yesterday, and now just opened it, and if I wanted to commit, it says like no changes detected.
So yeah, I mean, so there is no change, and that means that you already saved every change, and you have to push it. That's it. You have to push your changes to the repository, because you already registered all your changes into this commit, into this particular, your changes are registered in your current local repository, okay? Because you have this local repository on your computer. Every time you go and download something, it goes and creates a new repository on your computer. It's a local repository. And you have to register your changes through commits to this local repository. And when you say push, what you're doing is you're taking all these changes from your local repository and pushing them to the remote repository, which is in fact GitHub. Okay, this GitHub is a remote repository. It's located remotely in a different server, not on your computer. Okay, so you're pushing those changes back into this one, the ones that you registered with the commits. Okay, so just make everything cohesive. Okay, because you're basically developing this particular task yourself. These are the only things that you need to know: how to stage your commits. I mean, how to register, how to stage your things into a commit, how to commit things, and how to push things, or how to pull things back. Okay, these are the only things that you need to know at this moment in order to finish complete tasks. Okay, so and I don't think that you're going to have any problems with that. Okay, so we finished this task, right? So if you don't have any questions, we can move on to other tasks. I wasn't actually planning to cover this particular task, the third task, but there was a student who wanted to ask some questions. So can you go and ask your question right now? So I'll ask that, explain that, and then we'll move on to the task 4. So I'll show you how to do the task 4. Okay? Yeah. What was your question?
Yeah,
Someone
Professor,
was.
I have a question.
Okay. So please
Yes,
ask your
I
question.
didn't understand how to implement this program, because how we can use this table like items from 1 to 4, but these values are not equal to 5,000, or we should create a for loop and then calculate earnings of each salesman, or only one salesman,
Okay,
salesperson.
Okay. Let me read it out first for everyone, so everyone is on the same page. So a large company pays its salespeople on a commission basis, right? The salesperson receives 200 per week plus 9% of their gross sales for that week, because they have a fixed salary, which is 200 per week, and then 99% from whichever sales they did, right? So for example, a sales person who sells $5,000 worth, okay, merchandise in a week, he receives 200 fixed rate and 9% of this 5,000, which is 6,150. So altogether, it's going to be what? $850. So they're going to receive $850. You've been supplied with a list of items sold by each person, okay? So the value of these items are as follows, okay? So the first item, second item, third item, and fourth item. Okay, so develop a Java application that inputs one salesperson's items sold for last week and calculates, okay, inputs one salesperson's items sold for the last week, and then calculates and displays the sales bonus as anything. There's no limit to the number of items that can be sold. Right. So yeah, so the question is, okay, so you have to go and develop a simple console application, which basically asks 4 questions. Okay, so how many items? How many item 1 has been sold? This, not much. How many item 2s has been sold? And you have to go and enter, let's say 100, and then for the item 3 and for the item 4. Okay, and then finally you should basically output that particular salesperson's salary. So let's go and do it. Okay, I think we can do that one as well very quickly. Does anyone join GitHub Classroom successfully? Okay, so anything that you have, any problems, Holub John? You should just go and click that link. Okay, and then keep find whatever your name and then click this one. Okay, so let's continue doing this thing. So we'll go and create a new Java class, and let's go and call it sales, let's say payroll, something like that, calculator. Okay, so this class is called sales payroll calculator, and it's asking me whether I want to stage this thing. I'll just click this thing for now, so I don't want to add it all the time. I want it to be done automatically. Okay, so I'll go and I want my IDE to remember my choice, so I'll go and press add, and it remembers my choice. Okay, so again, same thing, public, static, void, start. Okay, so, and here, what should I do? First, I have to go and ask the user to input the number of items sold, this one. But before I'm doing though, let me go and define some variables. So first of all, I would like to go and define, say, total salary, total wage or total salary, which is equal to 200. And it's default, right? So, I mean, no matter what the salesperson does, he's going to receive $200 per week, okay? So I'm just going and setting that to 200, okay? Just because this is just the base rate. Okay, so now I'll go and create another variable, call it item 1 value, right? And what is that number? Okay, 239. Okay, let me just round it out to 240. So I'll go and say 240, 0, right? So it's just a double. Okay, I can simply write it like this one. Anyway, this will be converted to double, even if this particular literal is an integer. Because of because of broadening, broadcasting, these things get converted into double implicitly. So let me go and create another variable called item2 value, right? And it's okay. It's just some number. It's like 139.75. Let's go and write it like this. 79.75, I guess, right? 39, sorry. Yeah. So these are just numbers. Item 3 value is equal to 35.49. So note that we haven't covered arrays yet, and therefore I'm just storing everything in this in a weird form like this. Okay. In a normal way, I would obviously store things in an array, but because we haven't covered arrays, okay, so I'm not just going into the arrays and then making some sort of confusion. If you already know arrays, okay, it's fine. But let's solve these kind of problems, okay, in a way that we kind of we know right now. So we assume that we don't know arrays and solving this problem. Okay, 350, 89, 350, 89. Okay, these are the values. Okay, good. So what should I do next? I think pretty simple, right? So what should I do next? These input, okay, the number of, okay, total amount item 1 sold. Okay, and the user has to go and provide some number. Okay, so I can go and say, and I'm pretty sure it's going to be an integer. So I'll say I1, okay, or N1. Let me go and call it N1. And it's equal to what? System. Yeah, system. Yeah, by the way, I forgot to create a new scanner object. I just need a scanner object, which takes the input from the user. And it should be system.in. So I got this input. I'll say next integer, right? And because the numbers are in integers, right? So I'll get n1, and let me just copy that. I'm a bit lazy, okay? So I'll go and say 2. And I'll go and do the same thing that I'll do for the item 3. And probably you're also already guessing that it's going to be item 4 and N4. And that's it. And what I need to do is I just need to find the total salary. What is the total salary? What is the total salary? Total salary is equal to, okay, is equal to N1 multiplied by item 1 value plus N2 multiplied by item 2 value and 3 multiplied by item 3 value, and then N4 multiplied by item 4. So note that I'm not assigning it, I'm incrementing it because I got a base payment here, right? I don't want to override this base payment. I want to have this base payment to be like this. And the next thing that I want to do is I'll say system out println total salary. Yeah, let's just use printf because we have some number to display. Let's say total salary of an employee is, and some, let's say, some fractional number, and I'd like to display total salary. That's it. And there our program exits. Okay. So now we finish this particular task. What I need to do is I have to come here. Let's say problem 3, right? Problem 3 solution. And I have to say sales payroll start. And let me go and start that. Yeah. And it's asking me how many items I sold. Let's say 45, 12, 32, and 41. And I got a pretty solid salary, right? 20, almost 28,000. I mean, more than $28,000. It's quite a big salary. Okay, so
Professor,
yes.
there should be some percent of total salary, total sold products.
Sorry?
Should be percent, 9% of total salary.
Oh yeah, exactly. Yeah, yeah. I was thinking, yeah, the salesperson is a kind of is becoming quickly too rich. So it has to be, yeah, total 9%. So what we can do, to get the 9%, just multiply it by, right? And this gives us the 9%, right?
Yes, yes.
That makes sense. And we're just incrementing it to the base salary. So let me go and start that. Now we'll see something meaningful. Obviously, that was a big number. Okay, so 45, maybe 12, maybe 25, and 41. And it's like 2,000. Yeah, still good salary, but not that big. Yeah? Okay, good, right? So is it clear? Is it clear?
Yes, clear. Thanks.
Yes.
Okay, good. So now let's do this particular exercise. The exercise 4, we have to find the largest number. Okay, and we have to do it. The most interesting thing, we have to do this without any notion of an array. Okay, how can we go and do that without an array? Yeah, there are a lot of algorithms that help you to do sorting, and because you know how to sort, you can basically find the largest numbers. But okay, we can do those things without lists and without arrays and then without sorting. I just need to go and run a simple algorithm for that. So the process of finding the largest number is very kind of frequently used in computer applications. For example, a program that determines the winner of a sales contest would input the number of units sold by each person. The salesperson who sells the most units wins the contest. Okay. We have to write a Java application that inputs a series of 10 integers. So we have to input series of 10 integers and determine and print out the largest integer. Okay. So the program has to ask the user to enter 10 different numbers, and they should be integers. And then at the end of the program has to tell which number was the greatest. Okay. So, and also your program should at least have following 3 variables. It has to have counter, which represents the number of inputs have been made so far. The number, which represents the current input that the user entered, and the largest, which has to represent the largest value, the largest number that is found so far. Okay, so we should go and yeah. So okay, good. So and then we can go and make some modification to find out 2 largest numbers. Okay, the top 2. But okay, so and you can go and do the same thing for finding the smallest one. But first of all, let's go and implement the first one. Okay, so what I'll be doing is I'll go and create a new class. And I'll call it find largest number. And as usual, I'll go and say public static void start. Okay, So now what should I do? Obviously I need a scanner because I'm going to collect user input. So I'll go and say system in. I got my scanner. Now what I need else? I need an integer, which represents the current number of total number of inputs entered. And then I just need a variable called number, which represents the current number. And I need another variable called largest, but this largest has to be the number that is kind of which represents the largest number so far. So in order to make sure my algorithm works, okay, I just need to set this particular number not to 0, because it takes 0 is not the largest one. I just need to go and make sure that it is set to minimum value, okay, of the integer. So this is the, you know that this is the standard integer, and standard integers have, okay, they use 32 bits. Okay, in these 32 bits, the first bit is the sign, so they can take negative and positive numbers. The min value represents the minimum number that particular integer, 32-bit integer, can hold. Okay, and I'm just setting it to be the minimum number because I want any number to be greater than this largest number, any number in my list to be greater than this number, okay? Because this way I'm going to find out which number is the largest. Okay, what is next? What should I do next? I just need to go and do some loop, okay? So how do I do the loops? So I'll say for, by the way, I don't need this count because I can determine this count inside my for loop. So I'll say is equal to 0. And what is the condition for my count, for my loop to stop? A loop continuation condition, not to stop. Loop, what is the condition for my loop to iterate? It has to be less than 10, right? And I just need, this is the condition that I use that I execute. This is the action that I execute at the end of each iteration, okay? So I'll do my iteration and then I execute this particular thing, okay? So this is my for loop. And what should I do next? I have to ask the user to give me, okay, the number. In fact, I don't even need to go and declare it here. I don't need it anywhere else. I'll just go and declare it here. So I'll say int number is equal to input next int. But before that, let me go and tell the user that he has to go and enter some number. Okay, so I'll say so let me go and use printf again because I want to embed some value into it. So I'll say please enter, and this should be a digit. Okay, say this or number. And I'll say count plus 1, okay? Because my count is starting from 0. I don't want 0th number, okay? So I want to say first number instead of third number and so forth. Okay, so this is how it works. Yeah, someone is asking a question. Okay, so someone is asking why we're using nextInt. NextInt is again this scanner is an object is an object which helps us to parse the user input, and you know that the user just types in something like it could be a string, it could be any number, it could be an integer or double, right? So we don't know. User simply types in something to the console, right? But the scanner is an object which can extract from the user input a corresponding data type. So we are telling here, we say nextInt, we're telling the scanner to wait when the user goes and inputs some data. And then when the user goes and inputs some data, the scanner will go and try to convert it into an integer, not to a double, not to something else. So we're saying next int. And now it's assigning that converted value, an integer, into this particular variable. So now what we're going to do with this variable, we're going to check, okay, if this variable, sorry, if number is greater than the largest, right? If the number that the user entered is actually greater than our current largest, the largest that is so far is the largest one. But at the beginning of our program, we set it to be the minimum number. Okay, in an ideal world, obviously this would be some negative infinity or something like that. But we don't have the concept of negative infinity in Java at this moment. That's why we're using just a minimum integer that can be entered in this one. So there cannot be number which is less than this. Okay, at least for this particular data type, integer data type. Okay. Yes, someone is asking. No, okay, you can use arrays, but this one, we haven't covered arrays in this lecture. And again, sometimes it could be a kind of a challenge to do things without arrays, but try to do things without arrays, because like they can be simpler solutions, and you can find these solutions and just use these solutions, right? So just take it as a challenge. I know, yeah, you had the computer programming class before, and you are familiar with the concept of arrays. I'm pretty sure about that, but we haven't covered it in Java, and therefore I'm not going to ask you to do something with the arrays. Try to do things without array, and these problems can be solved without arrays and much more efficiently, okay? And will take less memory as well. So think from that perspective. Take it as a challenge, okay? Can I go and solve this problem without using an array? And then you can go and do something meaningful. We'll cover arrays and methods, okay, in the next lecture, and we'll go through those arrays and different things, not just arrays, but array lists as well. And we'll see what you can do with these arrays and how you can solve different problems with the arrays using Java. These are kind of the Java fundamentals part 2, but we just need to go through those things, okay, in order to make sure that you are familiar with the Java syntax before we go and start doing something really interesting, like designing applications and making some GUI parts and all that kind of stuff. Okay, so we just need to cover those things in the first 3-4 weeks. Okay, good. So yeah, if you don't have any questions, sorry, so I've got any question. Yeah, got it, right? So, okay, good. So we got number greater than largest. And if it's greater than, what we're going to do, we're going to say largest is equal to number, right? So we now, this is the largest number so far. Okay, great. So now we got a for loop, and this for loop will run 10 times, and then it stops. And at the end of this for loop, what should we say? We should print out the largest number. The largest number is, and let me go and say digit, and then the largest. And that's it. We basically solved this particular simple problem, right? Cool. So now we can go and test it. So this was a problem number, yeah. Yeah, this is the problem number 4. So we're going to say problem number 4, solution, and then we should say find largest, start. And I go and press next. And it's asking me to enter. Oh, I forgot to break the line, so let me go and break the line. See, it's a printf, so I have to break the line, otherwise it will be clumsy. I'll go and say n, and I have to go and say n. The printf will not break the line. Println will break the line. Printf will not, so I have to break the line. I have to append a new character called new line character to make sure that it's the caret starts from the next line. This way it will be easier for me to interact with the program. Okay, so I just went on and made the change. So let me go and see. Okay, now it's asking me to enter the number. So let me go and enter 14, maybe 15, 12, 10, 9, 17, let's say, okay, maybe 14 again, 10 again, and maybe 19, and let's say 2. And you can see that it works correctly. It says 19, right? So 19 is the largest number that has been entered into this program by far. Okay, so we basically solved the problem. So the question is, okay, how can I go and store the second largest number? How can I do that? So any ideas? I can store the second largest number.
Just to create another variable, like largest second.
Okay.
And set it also to the minimum value.
Exactly.
Then we have to add one more if conditional statement.
You sure?
I think.
No.
Maybe you will make the same, but minus largest.
Minus largest? No. What do you mean minus largest?
Vanish largest. Make the same, but without largest. It will be the second largest.
Maybe else if, like else if number bigger than largest
The
2.
same, but
then
if it is the largest.
So yeah, Nilüfer
it will be
Tokhirova
another.
is giving a good idea. She's saying, yeah, Nilüfer, can you talk? Yeah, Nilüfer Tokhirova is saying a good idea. She's saying we have to do something inside existing if. Yeah, so she's up to something. So what should we do? So yeah, think what we can do inside this if. Yeah, think. Okay. Exactly. So Tokhirova is she's brilliant. Okay, so Tokhirova actually answered the question. Nilüfer Tokhirova. Okay, so we have to see the problem here. The point here is whenever we find a number which is the largest one, right? So we're sliding the list through the list, right? So that's when we have to change the second largest, right? So what we need to do is we have to say largest second becomes the largest, and now the largest is the one, okay? Or I can go and call it, but this is the second largest, right? Okay? Yeah? So every time I find a number which is greater than the largest, what I'm doing is I'm just pushing this thing down, right? I'm saying, okay, now the largest is changed. The largest is changed and it's equal to number, right? But the previous largest becomes the second largest, right? So yeah. So let's print this out. Yeah, and 13, and again 10, and maybe 18 and 10 again, and maybe let's go with 17. Oh, I didn't print out the, oh goodness, I didn't print out the second largest. Okay. So this is I think this will not work, I guess, because we have to compare it with the number as well. This will not work. But anyway, let's go. Because yeah, this number could not be yeah. So I think that will not. Yeah, this is something we need to do when we are changing the largest. But I think we also need to check if this number is greater than the largest 2. If it's greater than the largest 2, we have to replace it with the largest 2, right? So I think we have to go and do the else if part as well. This way, I think it will be complete. Because, yeah, someone is saying something. This is gonna work, right? I just thinking, okay, the case, okay, where the it was the yeah, because we're entering the things in a sequential way. Now let's say we got a sequence, okay. The sequence is we got a sequence is okay 2, 10, and 8, right? So 2 will be the largest number, okay, and with this code, 2 will be this. The 2 will be the largest number, okay. So the program will write it like this first, and then in the next loop, okay, we enter 10, so it goes and sets it like this. So okay, 10 is the largest number, 2 is the second largest number, right? Yeah. So now we are entering 8, and okay, but 8 is not greater than, okay, 8 is not greater than 10. So obviously this 2 will not be updated, but 8 was entered, right? So obviously this is not going to work. And
it's gonna work because we'll swap the largest number to second largest number. So
no, wait. The first number you entered was 2, right? And the 2 became the largest number, right? And then you entered 10, right?
Yeah. We should add second option when. Yes,
yeah.
You're right.
So
you're
so
right.
10 becomes the largest number, 2 becomes the second largest number, right? Yeah. And then you're entering 8. So what you're going to do is you compare 8 to 10, right? And 8 is less than 10, therefore this part will not work. So the second number will remain unchanged. Got my point. So we have to add this else if part where we have to check where the number is greater than the largest 2. And if it is greater than the largest 2, then, okay, then we have to say largest number 2 is equal to the number. This way, we can be sure that if the user goes and enters 2, we first check it for 10, and if it's okay, less than, okay, this swap will not happen. Okay, but it can go and check it to this one, and if this is true, then it goes and replaces 2 with 8. Okay? You got the idea?
What if after 8 it will go 3? Will it work?
After 8? After 8, 3? This one?
For example.
Yeah, yes.
Yes.
So it will go and check 3 with 10. It's less, so no swap happens. it goes and checks it with 8, no swap happens. These are still the 2 top numbers, right? Yeah, so it will work, right? Is it clear? This part, again, this part we should add as well. We have to add the else if part. So I was thinking, okay, maybe we'll just get away with this one, but no, I give it a little bit thought, and then yeah, we just need to add this part as well. Okay, so and this way we just basically solve the problem. Okay, so I can go and test this application. I'm pretty sure it will work. Yeah, try to visualize things, okay, and solving it. Okay, with the real numbers, you're going to see that okay, some of your solutions will not work. If you have the real numbers in your head, then see what your algorithm is doing. Okay, good. So we got 10, we got 9, we got 17, we got 13, maybe 14, 16 again, 11, 10, and 9. And here we go. The biggest number was 17, and the second biggest number is 16 indeed. Right, so it's basically doing what we actually did, right? So cool. So we solved the problem. Okay, you can do it yourself. Okay, for the third task where you have to find the minimum numbers. I think it's pretty simple. You know what you need to do. Can someone tell me what should I do? What should I change to make things find the minimum rather than the maximum? Yeah.
If the number is smaller?
I just did here, this one finds the maximum numbers. What if I want to find the minimum numbers? What should I do?
Within the if, we have to change the sign. Instead of bigger, we have to set smaller.
Yeah, smaller, and we also need to change this part, right?
Yeah, to the maximum value, right?
Yeah, to the maximum value, exactly. So this way, yeah, we will have we'll have our algorithm to find the minimum, not the maximum. So just small changes, and you basically done. Okay, good. So we solved the problem for this one, and we would like to solve this particular problem, the palindromes problem, and I'll just leave this the remaining things for you to complete yourself. The triangle printing problem, approximating pi, and then Pythagorean triples. Okay, so you can do those things. Just give it a little bit of thought, and then this one. Let me just show you the palindromes, how to find if a given input is a palindrome or not. Okay, so before we go and start doing it, let's go and read that. So it's palindrome is a sequence of characters that reads the same backwards and forwards. So for example, each of the following 5-digit integers is a palindrome. Okay, so these are palindromes. We can read it in both directions, and it will not change. So we have to write an application which reads 5-digit integers. So it has to be an integer, not string, and it has to be 5-digit integer, and determine if it's a palindrome or not. If the number is not 5-digit long, then display some error. Okay, saying, okay, you entered the wrong value, something like that. Okay, so let's go and do that. So I'll go and create a class called palindrome finder, and I'll just say public static void start again. Okay, so now obviously I need a scanner, which is an input, new scanner system in. Okay, so what should I do next? I just need to take the input from the user. So please enter your digit or number. Yeah. I'm done with it. All the tasks I have commit them, push them. That's it. It's called submitted. Yeah, that's cool. So Sherlock Holmes said that he's done. Okay, cool. So if you finished it, that's fine. That's good. But for those who haven't finished, just showing. Okay. Yeah, so what we need to do here, we just need to collect the user inputs, and it has to be an integer, right? So let's say the number has to be an integer. I'll say input next int. Okay, cool. So now what should I do is I should go and first check if this number is a 5-digit number. How do I check it? Yeah, how do I check that? It's not a 5-digit number. I mean, it's a 5-digit number. Okay, all I need to do is I just need to check if it's not less, okay, if it's less than 10,000 or greater or equal to 100,000, right? So I just defined the range, right? So if the number is either less than 10,000 or equal to the 100,000 or greater than that, then it's not a 5-digit number, right? You agree with me? You agree with me?
Yes, yes.
Okay, so if this is the case, it's not a 5-digit number, then I have to tell the world that the user that he actually entered the wrong number. So please, I can say you entered wrong number, and maybe exit the program, right? I'll just say return. Okay, so this error is an error output. I can go into let's say print something from it on an error output channel as well. But okay, if the number is correct, then I'll hit the spot and I can go and do my tests further. So I would like to extract the first digit of a given number. Let's imagine that my number is, I don't know, say some number like this. Okay, and I would like to extract this number. What should I do? Yeah. Tell me, what should I do? I have to find the modulus, okay, of number divided by 10, right? So if I just divide it by 10, all of these parts will be gone. Only this part will remain, right? Yeah? You agree with me?
Yes, yes, yes.
So now I just need the second digit. I want to find this digit. What should I do? This digit. What should I do? I have to divide integer division by 10, right? And then if I divide it integer by 10, then I'll have this part. This part will be gone. It will be truncated, this part. And now it's again the same problem. I just need to get this part, right? So it's like this, right? You agree with me?
Yes, yes.
Yes, it's right.
So in order to make sure to check 5-digit number, if it's a palindrome or not, what I need to do, I need to check the first digit with the 5th digit, right? I need to compare the second digit with the 4th digit, right? I don't care what is in the middle, right? I don't care what is in the middle, right? You agree with me? So I just need to find D4. So how can I find D4?
So we divide it into 1,000.
Exactly, and the same principle.
Yes.
And oops, and D5. Yeah. Agree with me?
Yes.
Yes, it's right.
Okay, it's 10,000, and yeah, if I divide it by 10,000, yeah, if it's this one, okay, it will be just 1. If it's 2, it will be just 2, and that's it. I don't need to find the modulus in this case, right? Yeah, I mean, I can leave it like this, and nothing will change in this case, okay? I mean, just for consistency's sake, I can just leave it like this, okay? For readability's sake, but again, this is not important. This part is absolutely not important. Okay, good. So now what I need to do next, just need to return, or I just need to say, okay, I need to create a Boolean, say is palindrome. And what is equal to D1 equal to D5. And at the same time, D2 has to be equal to D4, right? If this logical expression is true, right, then this is a palindrome, right? You agree with me? Yes or no?
Yes. Actually, we could do with if expression, no?
Yeah, I mean, you could do this with if expression, but always think from the readability perspective of your code. This will make your code better readable, right? I can go and say, let me just go and say println. Yeah, you can do it this way. You can say if is palindrome and see, you could go and copy this in and put it here, right? But it would make your code less readable because you didn't know what you're actually doing here, okay? But now you know, you're checking for that if it's a palindrome or not, and then you're printing out the message. So this makes your code readable, okay? So don't spare variables, okay, when the cost of your readability is on the stake. So make sure that, okay, your code is readable, and so you can go and create a variable and then check for that variable. So this way the code is understandable for others. Okay, I can go and say print this one. I can go and say print system out, but I don't want to use if statement here. I want to use something else. So let me go and say system out println or printf, and I'll say it is and here what I would like to do is I got a placeholder, a string placeholder, and if it's empty, then it is a palindrome. If it's not, if instead of s I put a not, then it is not a palindrome. So I can go and say, I can go and use if, inline if. So I can say palindrome. If it's a palindrome, then it is empty string. If it's not a palindrome, I just say not. So this not will be placed here, and it will say it's not a palindrome. If it's palindrome, then this not will not be placed here, and it will be a palindrome, okay? Okay, good. So now my program exits. I can test it. Problem 5, solution. And I can say palindrome finder, start. And I can start my program. And now let me go and deliberately enter non-5-digit number, let's say 41, and it says you entered the wrong number, which is good, which is the right message. And so let me go and enter 5-digit number now, and let me go and enter something else like this, and it says it's not a palindrome. And let me go and check for the case, which is palindrome, and it is saying it's a palindrome, okay? So now we did the problem, we solved the problem. So now, okay, let me just save it like this. And now I just want to first commit my changes. So I say finished problems, and which problems you finished? 3, 4, and 5, right? So you write down this thing, and then you press commit, and it finishes, you've saved the checkpoint, and then next thing is push. Don't forget the push, because without push, your changes will not be uploaded to the repository. Now we press the push, and it goes to your repository. Always after pressing push, you have to go to your repository and double check. You refresh your repository, okay? And then you go here, and first of all, I mean, if you see your last commit message, then it means that your last changes have been pushed, okay? But you can go and check files as well. You can see this last commit message. It means that, okay, you pushed your changes. Now you're okay. Now you can go and and call it a day. Okay, so that's fine. So now you can see your files there, and then all that stuff. So it seems like you did your work. Okay, but you still have some other tasks to do. So you can do it yourself. You have basically this 3 and maybe 4 tasks remaining, and you have to do it yourself. Okay, I understand that it's been quite longer than today because I wasn't planning to do this part. Okay, but anyway, I showed that. So, but anyway, hopefully it was useful. So please finish your lab exercises on time. Don't miss the deadline. And so you'll have another lab next week up till the end of the semester. Okay, so don't just procrastinate. Okay, don't postpone it till the last minute. Otherwise, you won't be able to cope with everything at the same time. Any questions so far? Anything that you'd like to ask me? Yes.
Can I ask about GitHub, how to use it? I did all rules which you recommended us, how to create it and how it located. But in my app, IntelliJ IDEA main Java, it's red. I don't know why and how to change it. I created in that pathway how you recommended.
What is
in your IntelliJ IDEA is app Java, and in my main .java, but it's red, and I don't have
because you open it, yeah, because you open it or something. You made a syntax error, or you go and try to create a new new project, okay, with IntelliJ. New project somewhere else and try to create this one. I think you didn't create it in a right way. Maybe you created something else. So I will upload the videos, and you please watch exactly what I did and see what you did yourself, and just repeat what I did. So you'll have exactly the same thing. If even after that it won't work, then maybe you show me the screenshots. Okay, you send an email and send screenshots that every step that you did with the screenshots, and maybe I'll be able to figure this out. Okay, for you. But again, before going and doing this, watch the video. I'll upload the video and see exactly what I did. You have to create a new project, and this new project has to be Java, not something else. Because maybe you chose something else. Maybe you chose Android, whatever, and this is causing the problem. I don't know exactly right now. You have to do it exactly the same way. And that's the reason I want you guys to install exactly the same software that I have on my computer. Otherwise, we're going to have these kind of problems all over again. And this is going to take a lot of time. So so my recommendation is go and try exactly what I did on a different folder, on a completely new folder. And if it works, then it's fine. Then you can remove all the files from that, or you can clone your whatever project to a different folder, and then start things from the beginning again. Okay, and regarding the things that if it doesn't work, okay, then send an email. Send an email with the screenshots, and I'll take a look and then I'll reply back. Okay.
Okay. One more question, Professor. Will you upload this video today or when?
I'll try to upload it today. Okay.
Okay. Thanks. Thank you very much.
Yeah. Sorry, but here, when we must make a screenshot of the projects for every project.
Yeah. You will be doing this for every lab. Yeah, you'll be doing this. So you'll have this lab links every time, and then you should be doing this kind of things every time. Okay, it's every week you're gonna have this. Is it clear?
Yeah.
Okay. So yeah, please make an attempt, do something, and also consult. I'm telling you that go and organize yourself into study groups. So try to solve the problem, whichever problem you're facing within the group that you have, and try to different options. And if everything is not working and you tried a lot of different options, then you can write a comprehensive email back to me saying, Professor, we tried this and that. We are like a student of, we are 3 or 4 students trying to solve this problem, and we cannot solve it. and we tried this, that, this, and you include those screenshots to me, and I'll take a look, and then if I can solve that, I'll let you know what you need to do. Okay, but before doing so, you have to make a genuine effort, okay, to solve it yourself with your students. But the rule of thumb is do exactly what I did on my screen. Don't deviate to anywhere. If you deviate to some place, you're asking for a trouble. Okay, and then we will have a lot of headaches with that. So if you're not kind of professional Java developer or someone who's not using Java for quite a bit, okay, then you better stick with what we are doing on a classroom. Don't try to deviate, okay? That's my general recommendation. And because I see a lot of students try to jump ahead, they want to know more, and then they want to jump ahead, and they just put themselves in a big trouble in the future, because they will not understand what they're doing. They will have a lot of problems, and that will waste a lot of time with them. Okay? So if you don't have any questions, okay, thank you for attending this session. I'll upload the videos, and so see you next week then. Okay, and if you have questions, please contact me by email. Okay, or post your questions into our, we have a in our online in.us, we have a portal. I have a special place where you can post your questions. Okay, you can post your questions there too. I highly desire to post. You will post your questions there because everyone can see that, and if everyone have similar problem, they can have those problems solved. Okay, is it clear?
Yeah, clear.
Yes, thank you.
Thank you very much.
Professor.
Yeah, thank you very much. So see you next week. Please do the exercises, everything, and finish them on time. Okay, see you.
Okay, goodbye.
Thank you, Professor.
Yeah, thank you.